Hey guys, how you're doing? Today we're gonna talk about derivatives and tangent line. So grab your pen and paper and gonna see you in a minute. Derivatives and tangent line are deeply connected to each other. For example, if you want to find the tangent line at any given point a to the function x squared, we discover that the slope of the tangent line is exactly equal to the value of the derivative, in this case 2x, at this given point a. In general, the equation of the tangent line to a function f of x at the point a is given by y of x equal to f prime x minus a plus f of a. I want to compute the tangent line to the function f of x equal to 3x squared plus 2x plus 1 at the point x equal to 0. So let's recall the general formula. So the tangent line at any given point a to a function is given by y of x equal to f prime of the point of tangency, x minus the point of tangency plus f of the point a. And now we have to apply this formula where f is equal to 3x squared plus 2x plus 1 and a is equal to 0. Great. So what we have to do? Well, we have to first compute the derivative. So f prime of x is equal to 6x plus 2. And then to apply the formula, what do I need? Well, I need the value of the derivative at 0. So f prime of 0 is equal to 2, because 6 times 0 is equal to 0. A is equal to 0, because it's my point of tangency. And f of a is equal to 1. In this case, because a is equal to 0, so when I plug a equal to 0 in the formula, I get just 1. Therefore, my tangent line becomes y of x equal to 2 times x minus 0 plus 1. As a second exercise, I want to compute the tangent line to the function f of x equal to e to the 3x minus 3 plus x power 3 at the point x equal to 1. So as before, we have to use the same equation for the tangent line, but now the point a is going to be equal to 1. So let's write it down. A is equal to 1. So we're going to need f evaluated at the point 1, which is equal to e to the 3 minus 3, I get e to the 0, which is 1, plus 1 to the power 3 is 1, so 1 plus 1, this is 2. And at the end, we need to compute the derivative, f prime of x, which is equal to what? Well, we have to differentiate it with e to the 3x minus 3, which is e to the 3x minus 3 times 3, because I have to remember to differentiate also the exponent, plus the derivative of x to the power 3, which is 3x squared. And then I have to evaluate this derivative, f prime at the point equal to 1. And I get e to the 0, which is 1, times 3 plus 3 is 6. Therefore, my tangent line is y of x equal to f prime of the point is 6 times x minus a in this case is 1, so x minus 1, plus f of a, which is 2. As a last exercise of today's video, I'm going to compute the tangent line to the function f of x equal to the sine of the log of x plus pi over 2 at the point x equal to 1. The formula will not change, but the derivative is going to be slightly more complicated. So let's start by saying that the tangency point has to be x equal to 1, therefore a is going to be equal to 1, and we can compute immediately f of a, which is f of 1, which is equal to, so we have to compute the sine of the log of pi over 2, the log of 1 is equal to 0, so I have just the sine of pi over 2, which is equal to 1. And now we have to compute the derivative, so f prime of x is equal to what? And this is a chain rule, so first we compute the derivative of the sine, which is the cosine of the log of x plus pi over 2, times the derivative of the log, which is 1 over x. Perfect. And then we have to evaluate this at the point x equal to 1. And we get that the log of 0 is still, the log of 1 is still 0. The cosine of pi over 2 is 0. So f prime of 1 is 0. So we can apply the formula, and we do get that y of x is equal to f prime of 1 is 0 times x minus 1 plus f of 1 is 1, which can be simplified as 1. So this line is just parallel to the x-axis. To conclude, I just want to show you how crazy becomes the tangent line for the function sine of x. That's all I have for you today. See you next time.